Here's a bonus example of an E1 mechanism where you have a strong base. So let's look at the situation. You have the cyclohexane with its two methyl groups over here, dimethyl, and you have on one of the methyl groups, you have a bromine. And so this carbon, the methyl group, is a primary carbon. Now, you have a strong base, strong nucleophile here, methoxide ion. So generally, you would like to do a SN2 reaction. But notice that your neighbor over here is a quaternary carbon. So if we label it, quaternary carbon is too much steric hindrance for an SN2 reaction to happen. So you won't get SN2. So you'll look for E2 because you're still a strong base. But then again, you have no hydrogens from which you can do an E2 reaction. So neither can you do SN2 or E2. So what's possible for it to happen? Well, the only possible thing for this to happen right now is for bromine to leave on its own. And so you get this intermediate. You get this intermediate right here, a primary carbocation. Now again, a primary carbocation is pretty unstable. So what's likely to happen is to get a methyl shift. Now you can also do a ring expansion, but methyl shift is more likely to happen since it's a smaller group that's moving. So plus a cyclohexane is the perfect shape for angle strain. So ring strain happens when you have really small rings, and cyclohexanes are almost the perfect shape to produce the least amount of ring strain. So a methyl shift is more likely to happen than a ring expansion. And so if we do a methyl shift where we move this methyl group over here, we're going to get this other intermediate. It's a cyclohexane again, but now it's a ethyl group. And we have a carbocation right in the middle over here. And now our strong base, the methoxide ion, CH3O, with a negative charge over here, is going to use one of its lone pairs and going to abstract the hydrogen. Now the reason it's not doing an SN1 mechanism is because it's a strong base, and it's more likely to abstract a hydrogen than perform a substitution in this situation. So we're going to have one of our hydrogens over here or a hydrogen over here, and we can get either product. And so we can get our product that has our cyclohexane here and our other product, other cyclohexane. So we can have the first one. If we abstract this hydrogen, we get our double bond right here. So we'll draw it in the inside. And if we abstract the other hydrogen, we can get our other double bond here. And then we also have the ring expansion product. So I'll say this plus ring expansion product, but I won't draw that simply because the ring expansion product is a little bit less possible than these two, and I'm a little bit too lazy to do it. So there you go.